I'm Dr. Binu. In IoT sensors and devices subject, the sixth topic in the first unit is humidity sensor. What is meant by humidity? Humidity is a presence of water in air. The amount of water vapor in air can affect human comfort as well as many manufacturing processes in industries. The presence of water vapor also influences various physical, chemical, and biological processes. Humidity measurement in industries is critical because it may affect the business cost of the product and the health and safety of the personnel. Hence, humidity sensing is very important, especially in the control system for industrial process and the human comfort. Controlling or monitoring humidity is uh, very important in many industrial and domestic applications. In semiconductor industry, humidity or moisture level needs to be properly controlled and monitored during wafer processing. In medical applications, humidity control is required for respiratory equipment, sterilizers, incubators, pharmaceutical processing, and biological products. Humidity control is necessary in chemical gas purification, dryers, ovens, full desiccation, paper and textile production, and food processing. In agriculture, measurement of humidity is important for plantation protection, soil moisture monitoring, etc. For domestic applications, humidity control is required for living environment in buildings, cooking control for microwave ovens. In all such applications and many others, humidity sensors are employed to provide an indication of the moisture in the environment. Classification of humidity sensors. Humidity measurement determines the amount of water present in a gas that can shed off air or pure gas such as nitrogen or oxygen. Most commonly used unit of humidity measurements are relative humidity, dew or frost point, and the hot spot. Relative humidity is a function of temperature and thus it is a relative measure. Dew slash frost point is a function of pressure of a gas but is independent of temperature and is therefore defined as absolute humidity measure. ppm, that is parts per million, is also an absolute measure. The definition of relative humidity is the ratio of partial pressure of water vapor present in a gas to the saturation vapor pressure of a gas at a given temperature. Dew point is the temperature at which the water vapor in a gas condenses to liquid water. Frost point is the temperature at which vapor condenses to ice. According to measurement units, humidity sensors are divided into two types: relative humidity sensors and the absolute. What are relative humidity sensors as well as its types? The first type of or gauge sensors, that is relative humidity sensors, are capacitive or gauge sensors. Capacitive or gauge sensors are used widely in industrial, commercial, and weather telemetry applications. Because of their low temperature effect, they are often used in wide temperature ranges without active temperature compensation. In capacitive or gauge sensor, change in dielectric constant is almost directly proportional to relative humidity in the environment. These sensors have low temperature coefficient and can function at high temperatures up to 200 degrees Celsius. They are able to fully recover from condensation and resist chemical vapors. Response time ranges from 30 to 60 seconds for a 63 percentage of relative humidity step change. Applications of capacitive Auger sensors, which is normally used in automotive onboard devices such as windshield defoggers, computer printers, medical devices such as ventilators and incubators, appliances such as microwave ovens, refrigerators and cloth dryers, HVAC systems, recorders and data loggers, leak detection, weather stations, industrial and processing equipment, environmental test channels. Advantages as well as drawbacks of capacitive RV sensors. Advantages are near linear voltage output, wide RH range and the condensation tolerance, interchangeable if laser trained, stable over long term. Drawbacks of capacitive RV sensors are distance from sensing element to signal conditioning circuitry limited. Second type of humidity sensors are resistive humidity sensor. These sensors measure the impedance change, which usually has an inverse exponential relationship to humidity. The impedance change of a medium, such as a conductive polymer, salt, or treated substrate, is measured. How to select resistive humidity sensors? Resistive sensors are small, low-cost humidity sensors that provide long-term stability and are highly interchangeable. They are suitable for many industrial, commercial, and residential applications, especially control and display products. Advantages as well as drawbacks of resistive RF sensors. Advantages are no calibration standards, so highly interchangeable and field replaceable, long-term stability, usable from remote locations, small size, low cost. Drawbacks are exposure to chemical vapors and contaminations may cause premature failure. Values may shift when water soluble coatings are used. The next type is absolute humidity sensors or thermal conductivity humidity sensor. These sensors measure absolute humidity by calculating the difference between the thermal conductivity of dry air and air containing water vapor. These sensors are constructed using two negative temperature coefficients thermistor elements in a DC circuit. One of the element is sealed in dry nitrogen while the other is exposed to the environment. The difference in the resistance between the two thermistors is directly proportional to absolute humidity. This diagram represents the thermal conductivity humidity sensor. How to select thermal conductivity humidity sensor? These sensors are commonly used in appliances, including cloth dryers and microwave ovens. They are used in many industrial applications, including wood drying kilns, drying machinery, pharmaceutical production, cooking, and food dehydration. Advantages as well as drawbacks of thermal conductivity humidity sensors. Advantages are very durable, work well in corrosive and high temperature environments up to 575 Fahrenheit. Better resolution than capacitive and resistive sensors. Drawbacks of thermal conductivity humidity sensors are respond to any gas with thermal properties different than dry nitrogen, which may affect measurement. How to select uh, thermal conductivity humidity sensor based upon their applications and the particular appliances or choosing the thermal conductivity humidity sensors. Thank you.